Hi, everyone, and welcome. Today, we're going to talk about the two big epic dances our planet is doing right now. These movements are behind everything, from why your alarm goes off in the morning to why you love sweater weather. So let's dive in. So, have you ever really thought about this? How can you be sitting in broad daylight while someone on the other side of the planet is deep in the middle of the night? Well, the answer has everything to do with the first of Earth's incredible movements. So here's our game plan. We'll kick things off with the Earth's daily spin, then we'll zoom out to its massive yearly journey. We're going to uncover the real secret behind the seasons, make 4 key stops throughout the year, and then wrap it all up with what you really need to remember. First up, the movement that basically runs our lives. I'm talking about the Earth's constant spin. And get this, it's happening right now, this very second, and you can't even feel it. Crazy, right? So the first big word we need to know is rotation. Just picture the Earth as a giant spinning top. It's turning on this invisible line that goes right through the middle, that's its axis, and one full spin takes just about 24 hours, which, of course, is what we call a day. So what does all this spinning actually do? Well, think about the sun. It's like a giant flashlight, and it can only light up one side of the Earth at any given time. So you can see here, whichever part is facing the sun gets blasted with light. That's daytime. And the other side, it's in the shadows. So that's nighttime. And remember, this isn't a static thing. The Earth is constantly turning, constantly moving different parts of the planet into the sunlight and then back out again. It's this beautiful nonstop cycle that we all live by. Okay, so let's zoom way out. Forget the daily spin for a second and think about the much, much bigger picture. Our planet's epic year-long road trip through space, and this is where we get the answer to why we have seasons. All right, let's just do a quick side-by-side so we're all clear. Rotation, that's the 24-hour spin on its axis, gives us day and night. Easy. Now, revolution, that's the big one, the 365-day journey around the sun that gives us our seasons. 2 totally different moves with totally different results. So, get this. While our planet is doing its daily spin, it's also on this massive road trip around the sun. We call that movement revolution. The path it takes is its orbit, and one full trip takes about 365 and a quarter days. By the way, that little extra quarter day, that's why we have a leap year every 4 years to catch up. And speaking of that road trip, how long do you think it is? Try 940 million kilometers. I mean, that is just a mind-boggling distance to travel every single year. It's absolutely massive. Okay, so we're revolving, but that's not the whole story. A lot of people think seasons happen because we get closer or farther from the sun, but nope, that's not it. The real secret, it's all about the Earth's tilt. Just look at this diagram. See how the Earth isn't sitting straight up? It's tilted, kind of like it's leaning over. And the really important part is that it stays leaning in the exact same direction the whole way around the sun. That combo, the journey and the tilt, that's the magic recipe for seasons. Okay, so let's break this down. We're going to make 4 stops on this year-long journey to see exactly how this tilt works. It's magic. Let's start at position A, which is right around March. At this point, the tilt is kind of sideways to the sun. See? Neither the top half, the northern hemisphere, nor the bottom half, the southern hemisphere, is really leaning into the sun. So what happens? They both get about the same amount of sunlight. That gives us those nice, mild seasons, spring up north and autumn down south. Okay, 3 months later, we're at position B, around June. Now look, the northern hemisphere is tilted directly towards the sun. It's getting hit with more direct, powerful sunlight for longer parts of the day. And what does that mean? Yep, it's summer. But for the southern hemisphere, it's the exact opposite. It's tilted away from the sun, so it's getting less direct light. That means it's their winter. All right, let's keep going. We've reached position C, around September, and this should look familiar. It's a lot like March. The Earth is sideways to the sun again, so both hemispheres are getting an equal dose of sunlight. The seasons just flip-flop. Now it's autumn in the north, and folks in the south are welcoming spring. And here we are at our last stop, position D, in December. It's a total flip from what we saw back in June. Now the northern hemisphere is tilted away from the sun. The sun's rays are coming in at a lower angle, the days are shorter. You know what that means? It's winter. Meanwhile, the southern hemisphere is tilted right into that sunshine, soaking it all up and having their summer. And just like that, we've completed a full orbit.
We've seen exactly how these two amazing movements shape our world from one day to the next. Let's just quickly run through the main things to remember.
So, when you think about it, it's actually pretty simple. You've got two main movements. Rotation, that's the daily spin, takes 24 hours, and it's why we have day and night. Then you've got revolution. That's the year-long trip around the sun, and that, thanks to our planet's tilt, is what gives us our seasons.
And that leaves us with one last cool thing to think about. What if the Earth wasn't tilted? What if it just spun perfectly straight up and down? What would happen to our seasons then? It really makes you appreciate just how important that little lean is for pretty much everything we experience here on Earth. Thanks for joining me on this trip.